All right, so my name is Boyan Krosnov. I'm the Chief of Product in StorPool. And this session is an architecture, then architecture deep dive, then a demo of StorPool. And we're a bit short on time, so bear with me. All right, so how does this thing work? First, kind of very high-level overview. It has a data plane. It has a control plane. In the data plane, there are a number of services, including the block device initiator. So this is the part that kind of attaches to the storage system. There's a server, which takes care of local drives in each node. There are a bunch of other services. Bridges used to connect multiple StorPool clusters over the public internet. So if you have 10 of them and you need to send data between them, that's how you do it. And the iSCSI target, in terms of the internals of the storage system, the iSCSI target is a client for the storage system. So it knows where data is in the cluster, it talks to servers, and on the other side, instead of exposing a local block device like StorPool block, it exposes an iSCSI target, right? And you can connect to that target. On the control plane, there is a StorPool API, and we have integrations with Kubernetes, OpenStack, CloudStack, OpenAbil, ONAP. There's a CLI and a GUI dashboard. Being the GUI dashboard part is just starting and it's being developed and improved at the moment. And there is a metrics collection side of things with a hosted analytics and monitoring platform. Hosted means it doesn't take resources on-prem, right? And there is no kind of additional infrastructure that our customer needs to take care of to do that. It runs on our servers. There is some common infrastructure underneath, CPU cores and memory, and I'll explain why that in a second. PCIe devices and other disks like hard drives and SATA SSDs, and the associated management of these with smart and all that. Networking, service discovery, so you don't need to configure things like IP addresses, right? It's just you plug them together and it just works. And there is a cluster management and quorum mechanism as part of the solution. All of this, everything you see on the slide, is something we developed. Over the years, we have tried kind of for particular ones of these to use ready off-the-shelf cluster management solutions, and mostly they didn't do a good job. Sometimes not because it's a bad product, but because it doesn't fit well in what we're trying to achieve, right? It doesn't fit well the why we're doing this. It doesn't correspond to that.
So the data plane is split across a client and a storage server?
Yeah, so this is, the color is not completely right there, but this is one physical host. On that, you would have a client for the StorPool that provides local block devices. And you may also have a server for StorPool which takes care of data stored on the local drives in that server. This can be deployed in a hyper-converged manner, meaning client and server on the same physical server, or it can be deployed on separate servers, right? And we're not religious about how you deploy it. So about half of our deployments are hyper-converged, the other half are on separate storage nodes. There are certain cases where one makes more sense and certain cases where the other makes more sense. In terms of kind of network topology, you could have 3 or more storage nodes, a couple of Ethernet switches, and tens of hypervisors, right? That would be a very typical deployment. The typical deployment is a very, very simple network. It's just 2 Ethernet switches. It's not like a huge network. Even though we do support these and we have these kind of huge data center networks used as a storage network in production.
Just out of curiosity, back to the network architecture, that one.
I forgot the two lines here, you mean, between the switches? No.
No.
Okay.
No. Although
yeah.
That would probably be a good idea. I'm curious about failover. Should a full storage node go down,
Yep.
what kind of replication or
Yeah.
striping is taking place?
So
in
the,
node to
the
node?
data protection and replication stuff. It's 3 copies in different nodes, and we'll get to data protection schemes a bit further down. So in terms of protecting network paths, we do multipath, but not like SCSI multipath our own way. And we very rapidly detect failures of individual links in the network, and we can handle normal failures. Say one of the switches goes out and you can use the path over the other switch, or also crossed failures, meaning say this link fails and also one of the links on the other switch fails. Mm-hmm. And then you have a kind of a second lower priority path which you can take that goes between the 2 switches. Right.
Just a quick question on the storage nodes. That's the storage aspect. The metadata aspect, is that a separate out-of-band service? Or is
no.
that something that
So-
runs on each storage node?
No, sorry. Okay. So the server component takes care of metadata associated with each individual drive. So it knows where data is on the drive, etc. And it also takes care of global metadata. Global metadata is things
Replicated.
like where data is across the whole cluster, right? In StorPool, this is kind of an embedded functionality inside the server. In a lot of other scale-out storage systems, there is a separate monitoring and metadata server cluster, right?
Yeah.
In StorPool, it's embedded in the server and it scales with the cluster.
I was thinking it looks very much like a Scale.io style of thing.
Yeah.
The only difference is they've separated, they have a metadata cluster
Yeah.
and a data cluster, which
Yeah.
can cohabit, but not necessarily.
Yeah.
But yours is built in, so there's one
Built in,
service
we
that does
we
everything.
don't separate it, and it's fairly lightweight, so there's not.
Yeah, there's not a lot of overhead for it.
Yeah,
Just
yeah.
to know if that's a separate service or
Yeah.
it's just part of the, you reel up a new
Part of
machine,
the same thing, yeah.
replicates the metadata. Okay.
Yeah. So I forgot the 2 links between the 2 switches. You definitely need these.
We guessed that.
Hit refresh, they're there already.
Did you fix it? Okay, let's try that. No. All right. So going further down. So this is a cluster of storage nodes and some initiator hosts. What happens inside one of these storage nodes is something like this. So you would have NVMe drives that talk to a StorPool storage server, which talks to a network interface card. When I say talks to, that means complete kernel bypass, meaning the storage nodes are Linux servers, right? But the Linux kernel is not in any way involved in StorPool server talking to NVMe drives or talking to the network interface card.
So how are you talking to the devices then? You're talking just to them as PCI?
So there is an NVMe driver in StorPool server, and there is a like Intel NIC and a Mellanox NIC and a Broadcom NIC driver in StorPool server. This is not this concept is not something we invented. It's called user space pole mode drivers, also known as kernel bypass. And Intel DPDK is another kind of example of that concept, although not the only one. It's just the most popular one.
And are you talking to the NIC directly?
Yeah.
With SRIOV, or are you going through the...
SRIOV.
You are, so...
Actually, 2 different ways. So for Mellanox NICs, it actually makes sense to do it in a different way. So not on Mellanox, we don't do VFs, which is SRIOV. We do, there's a Mellanox specific way of, you ask the NIC to create it, give you a queue, and it gives you a new queue.
Okay.
On Intel, it's with VFs.
But you're bypassing a lot of the Linux stack overhead, if you like. That's
Not a lot, 100%. Like there's
Okay.
no Linux code in the path at all.
It would be useful to draw that on that diagram to highlight, because that's clearly a positive advantage of your architecture.
Yeah.
That helps you deliver the performance.
Yeah, so this is one of the ways we get to such low latency levels, although it's not the only component. So this may be like 20% of the whole thing of how we get to this level of performance. If you think about it, so I've mentioned 250,000 IOPS per CPU core, right? So one CPU core would be 2 StorPool server instances, right? on adjacent hyperthreads. We pack them, and it's almost as fast as having a separate core. Which means each one of them is processing 125,000, say, metadata reads or metadata updates, plus getting the data from the drives and pushing it to the network interface card or vice versa, which is a lot of performance.
So when you're saying 250,000 per CPU core, you're talking about a storage server instance core.
Yeah, and on the client side, so there's a client instance here. Two of these, so one whole CPU core can push 500,000 miles. Right. So why does the client do more than the server? Because the client has less work to do. It doesn't have this metadata stuff. Right.
You said end-to-end data integrity, so there's some hashing done at the block instance, and that's checked
and in the server
instance and stuff like that.
Yeah. So in the right direction, so different obviously for reads and writes. In the right direction, when you give it data to write, the block thing creates a checksum. The server checks the checksum and then writes it to disk, right? In the read direction, it's it's
checked on the other side.
In the read direction, it's more optimistic because checksums are usually correct. So we get data from the drive, get it to the client. The client checks the checksum, and only if that fails, then we check it everywhere and see where the fault was.
And data is written in triplicate across the system, and the acknowledgement back to the block server is only done after it's copied to all three?
Yeah. Yes. We've looked at doing acknowledgement after 2.
Yeah.
We have looked at doing that. Haven't done that yet. Yeah.
Can I quickly ask, are you giving us a demo?
Yes. Sorry, I need to rush this.
Good.
So protection schemes. 3 copies. A lot of our high performance deployed capacity is 3 copies on mixed media, meaning 1 or 2 copies on SSDs. Half of our deployed capacity is 3 copies on hard drives, which is unusually low amount. So for most storage systems, hard drive would take a lot more. And before you bite my head off, yes, we're doing erasure coding soon. Okay, I know you're gonna ask. Yeah, and we have a special thing we do with writes and accelerating write operations, right? Which is normal. All right, so on to the demo.
Demo.
How are we on time?
Hour and a half, hour and 5 minutes.
All right. Pretty much okay, I think. All right, so first, the use case part of the demo, how people use it. Although this is not, hello.
So you support copy on write, so that metadata is managed at the storage server levels, I guess, right?
Yeah.
So I'm going to do a snapshot, use your API or CLI to do a snapshot.
Yes.
And that's all done at the storage server.
There is a global component. So the snapshot needs to happen in a consistent moment in time across the whole cluster.
Yeah.
And we also need to kind of drain the queue. So if there are a lot of outstanding operations, these need to be drained before you can snapshot. Otherwise, you get kind of an inconsistent snapshot. So there is a global component to it, but the timed out, what? This is OpenIBL. So this is the use case part. How do people use StorPool? Regularly, they wouldn't go into the storage system. They have a higher level management system because it's a cloud environment. Their end users, what they do is their end users would have a very simple view, and they're able to create virtual machines in that view. So take a CentOS 7 base image, and I want a VM with 2 vCPUs and 2 gigs of RAM. and I want that VM with this much storage, and they click create, and they get a VM, right? So this is all kind of the higher level management system. It's not usually not something we deliver, right? It's how our customers use it. In that higher level management system, there is a number of hypervisor hosts, right? And it also manages networks, but that's not so interesting. And it also is also connected to some storage systems, including StorPool. So you have the default data store. Under that data store, you have a StorPool storage system. Meaning, if you want to create a LUN in the storage system, you don't go and type CLI commands, or you don't go to the UI of the storage system. What you do is, in the cloud management system, you tell it, create me an image, and give the image a name. Proper name. Okay? And you say it's a data storage image, it's persistent, and it's going to be empty, and it's going to be 10 gigabytes, right? And when you click create, that creates a volume in the storage system, right? So for the most part, kind of creating volumes, deleting volumes, creating snapshots, our customer usually doesn't go to the StorPool, say CLI at all.
You've just got an API that just talks
Yeah.
from OpenNebula.
So there is an API integration with OpenStack, so you can go to kind of the OpenStack UI, and you can do these things. To CloudStack, same thing. OpenNebula, same thing, etc. Kubernetes persistent volume. You create a Kubernetes persistent volume. That's a StorPool volume, right? And then a level deeper. Let me just. Okay. Actually, I think I had that open. Nope. Yeah. Yeah, okay. So, how does StorPool look? You have the StorPool CLI. StorPool CLI is just an API client, meaning every command you have in the CLI, there is also an API call corresponding to that, and vice versa. If there is an API call, there is a CLI command.
And can you run that CLI on a management server, or do you have to log on to one of the nodes that is actually running the platform?
No, so you can run it on a completely separate server. The way the CLI talks to StorPool is via the StorPool API, so it's just an HTTP API
Right,
call.
so you could run the CLI anywhere.
As long as you have kind of the authentication token for the API. Yeah. And you can go in interactive mode, just do StorPool, press enter, and you get inline help by pressing question mark. Or you can do commands on the command line itself. So for example, a lot of our customers, the ones who do a custom integration with their stuff, a lot of them use the StorPool CLI as an API client. So instead of writing an API call, they would just use the CLI to wrap the API, if that makes sense. So what can we do in the StorPool CLI? We can look at services in this cluster. So these are kind of server services and client services. There is a bridge service and controller services and management services. Management is the StorPool API part. That's the API endpoint. These correspond to just these services, right? And the management service corresponds to that one. There are disks in this cluster. These are physical devices. For physical devices, you can also see their model and serial number, and you can use this device name to physically locate the device if you need, for example. And you can do things like eject this disk from the system, right? For example. There are volumes in the system, and so a volume list, and snapshots in the system. Sorry. Exit the volume list, snapshot list. Snapshot in the system. There is an external tool to do, this is the tree of volumes and snapshots. Do
you have a diagram that shows the hierarchy? So from what you're showing us there, It seems like you have physical media, and I'm guessing you chunk it up in some way, and then from there you put it into groups, and maybe you create volumes out of it.
Yeah.
Do you have a diagram that sort of shows that hierarchy of how you translate?
I don't. I should have, but I don't.
Perhaps do you have a graphical user interface as well, that, where we can see that?
We just finished the dashboard. I can show you just the kind of the view that says everything's okay, and this is the current load.
Okay,
right?
you don't have to get a breakdown.
Yeah, not. Let's do that. So, hierarchy. The way it's built up from top to bottom. There are volumes. Each volume, take one of these volumes.
And that's what's exposed to the client,
Yeah.
effectively.
So volumes, one thing you can do with volumes is you can attach them to hosts, meaning when you say attach volume BK test to client 1, what this translates into is you get a block device in dev StorPool. So there is a BK test block device on this host. If you change the name of the volume, the name of this block device changes. If you change the size of the volume, the size of this block device changes. So it's tied to the volume.
Yeah.
So these are, a particular volume, BK. The volume has map of where its data is across the cluster. And in this case, it's this drive and this drive and this drive for the first 1 megabyte of data of the volume, right? And these disks are just an SSD, and a hard drive across the cluster. How we choose these, how many copies and on exactly which drives we would select these, is controlled through volumes placement policy. So a placement policy, let's do a placement policy is how many copies, where should I put the first copy, where should I put the second copy, where should I put the third copy. These things are just lists of disks, meaning if you have a cluster with 1,000 disks, a lot of them are a particular kind of SSD. You just put them in the SSD group and you start provisioning volumes. You don't.
Yeah, it's a policy at that stage.
Yeah,
It's not
yeah.
specific placement.
So it's a hybrid volume, both disk
Yeah.
as well as SSD?
So this one is 2 copies on SSD, 1 copy on hard drive. And the only reason, well, not the only, but a very important reason that works is we do safe write back and sequentialization in front of the hard drive.
Yeah, I mean, the challenge with that is if you're doing a write, then you have to wait until the disk is actually written before you can acknowledge the write.
Unfortunately, one part we skipped because of not enough time
Yeah.
is write back, how we accelerate writes in front of devices. Not only hard drives, sometimes SSDs, but usually for hard drives. There is usually a power loss protected write back device in front of the hard drives, meaning writes go first to that. Traditionally, that was a RAID controller, right? Like an LSI RAID controller. More recently, that's an NVMe SSD or an Intel Optane drive. We consider the RAID controller like the legacy way of doing this. So in this protection scheme, latency of writes is the 2 SSDs and that write-back device in front of the hard drive. Latency of read operations is the latency of one of the SSDs. It would never read from the hard drive. If one of the SSDs fails, you still have one more copy on SSDs. So you're not increasing your latency because one SSD has failed in this particular protection scheme. And then a lot of, like when you create a volume, you don't go and for each volume select which disks do I want this volume on. You usually have many volumes with the same settings. The way that's scanned out in StorPool is we have this concept of a template. So when you create the volume, you just refer to the template. You don't give the volume its specific replication factor and drives, right? So the same way with integrations with higher level systems, they are, say, data store. Let's take one of these. So this is data store 1 in the OpenNebula system I showed you. When you create a volume in that data store, it will be with this replication policy and these on these drives. Okay. All right, let's see what else is on the demo agenda. Analytics. So in every StorPool cluster we deploy, we collect a lot of metrics. So that goes, we can both do high, overview, what is the load on the whole cluster, what is the latency that the whole storage cluster is observing. And we collect both at both ends of the path of I/O, meaning as close to the VM as possible, as well as latency of the underlying devices under StorPool. So you can think of it as, there is a workload, there is an interface between that VM and StorPool on the top. We measure there, and StorPool, and at the bottom you have between StorPool and a device under StorPool.
Just a quick question. You mentioned you had VMware support. Is that done with a VIB file, or how do you install your client in that situation?
In VMware, we attach VMware hosts over iSCSI, and
Okay.
that's with iSCSI VMFS, like very
Classic.
classic.
I was just wondering if you had a
Classic is a
native
good
client
word,
on that
yes.
one or not. But yeah.
Yeah.
Okay.
So you can both look at kind of the overall view of how many IOPS per second is this cluster doing at the moment, and there's this peak of latency here, and the reason there is this peak of latency is that it's like whatever 1 o'clock or 2 o'clock a.m. Where this cluster is. So this is local time, like 4 p.m. local time, right? And you can do things like top volumes. And this is, the way this works behind the scenes is you can think of thousands of metrics per second, really, coming into a metrics database. And everything we see here on the front end is just a query on that metrics database. And if you're kind of a more advanced user, you can go and edit these queries, right? It's just a query on the metrics database. And these are top volumes per number of reads for the last 6 hours. You can choose a different period, obviously. We can
Do you have a chargeback mechanism, so based on these metrics?
a what?
Chargeback. So do you have customer asking to monetize the single volume?
Monetize IOPS per second or size of volume or
Whatever.
no, we don't get involved in kind of
Service provider.
splitting the bill.
Service provider.
Yes. No,
Yeah, we don't get involved in splitting the bill. Most likely, we are not being asked about this stuff because vast majority of our customers have a cloud management system, so they have a system on top of StorPool
okay.
that keeps track of volumes, and
But you have QS, so they have
they can
fixed
they can
like
set
SLAs, and that's the top that you can get.
they can like attach a different IOPS limit to each volume. In some of these integrations, in others it's harder, but in some of these integrations it's a kind of either per volume, or you can set it for the whole data store, and then every volume you create out of that data store gets the same IOPS limit,
Okay.
right? And there have been cases where some customers would want, say, a different IOPS limit depending on the size of the volume, and that kind of, the StorPool API itself can't do that, but it's very easily scriptable. So it's very easy to do something that looks at the size of the volumes and sets the IOPS limit, right? So top volumes, and then you can also go to an individual volume, so per volume statistics. Oh, it's not this one. So in this case, it's a VM, which is a named virtual machine. It has a name. And that VM has a number of virtual disks, and the one that was fairly high, load relative to other volumes in this cluster was shared Hertz home, which is the home directory on that server. So this, gives you the ability to find who the heavy users are, to go back in time and answer the question yesterday 3 p.m. stuff was slow. Why was it slow? And also, more interestingly, it gives you the ability to look at live data as it comes in. So say update that every 5 seconds, apply that. So if you're doing, say, you're on the phone with your customer troubleshooting and you're doing a small experiment with them, if I try this, what happens, right? And this would, what's coming in here is the latency of storage operations on that volume, measured as close to the VM as we can go without installing an agent in the VM, right? And yeah, sorry.
Can I take any of that data out and throw it into another platform to analyze, or?
You could, yeah. So it's just a database query. Right?
Okay.
It's not MySQL, right? It's a metrics database.
Like language, yeah.
Yeah, but it has a query language, and you can take that data out. Something else that has happened a few times is some customers want us, in addition to sending the metrics data to our metrics database, they want a copy of that in their metrics database. And if they run the same database, which is InfluxDB, they get, we send another copy of the data to them.
Right.
As it comes in, right? Yeah, so these are new data points coming in, and they're per second data points, which has been very, very useful for troubleshooting. The metrics part, and as a final thing I want to show you on the metrics part, disable that one. In every cluster, we have a 10 IOPS per second test workload. So instead of kind of relying on collecting on the metrics collection or relying on internal metrics of the system, we have a completely separate piece of software that performs 10 IOPS per second and measures how the system performs. And this, in this cluster, it looks something like this. Right? So it's 200 microseconds average latency for writes and 130 microseconds average latency for reads on a production cluster with NVMe drives. Right? While everything else is going on in this cluster. Right? And it's obvious there is some spread in this, like it's not ideal, but the production workload is quite noisy, so you can see that being reflected here. Right?
And that's an all SSD volume, right?
This cluster is one copy on NVMe plus 2 additional copies on hard drive, and the hard drive
And you're
copies,
getting an average read of 132 microseconds, an average write of 200 microseconds?
Correct.
On a device that has 2 disks and 1 SSD?
And 2 hard drives, yeah. And the hard drives are obviously, you're not waiting for the hard drive media, you have like a power loss protected write-back device in front of them. Right? And this is a block device where the storage is consumed, right? It's not an internal metric of the storage system. We just perform the 10 reads and 10 writes per second, and we look at IO stat of that host, right? It's not an internal metric, it's the actual user visible metric, right? So take an example, what's in the 200 microseconds for writes? Sending the data over the network 3 times because it needs to get to 3 different servers, and it's usually not a local copy because unless the cluster is really small, they're all remote. Writing to the NVMe drive, writing to 2 power loss protection devices, say like the cache and array controller, right? And completing the I/O. From that cache and array controllers to the actual physical media, it may get committed to the physical media after power comes back, right? So in the worst case, power goes out then, and after power comes back, the RAID controller flushes that to the actual drives, right?
Yeah.
Okay.
So I mean, this drive obviously is on the order of 6-7 milliseconds, right, to write it to media. So you're You're acknowledging when it gets to the memory of the server?
Not the memory of the server, a power loss protected write-back cache in the RAID controller.
And power off protected is an SSD in the server?
Power loss, there are different ways you can configure this. In older deployments, we used to recommend RAID controllers with LSI's cache vault technology, meaning there is a super cap in the RAID controller, right?
Okay.
In newer deployments, it tends to be an NVMe SSD or an Intel Optane drive, which is, we recommend our customers doing that. Some still do RAID controllers.
They have some sort of non-volatile memory someplace in the solution that is your write log that you would write to.
When in this protection scheme, yes. So, for example, if you have 3 copies on SSDs, you don't need this. You don't need a device in front of the SSDs. They're fast enough, right?
Right.
So in front of hard drives, yes.
But your software-defined solution?
I didn't get the question.
Yeah, but you have a specific hardware that you're required to have for different configurations.
There is a hardware compatibility list. So not all RAID controllers behave the same way, and there's a short list of them. And I think that's the only way we can guarantee consistently good performance, right?
Yeah.
Okay. So that was the metrics part. Some screenshots of the metrics just in case, a screenshot of the dashboard. So some of the same kind of queries I showed you in the CLI, show me the list of disks, show me the list of volumes, show me the snapshots in the system and the network connections and all that. Although it looks really simple, right? This part here is kind of a lot of thinking and effort has gone into that. So when everything is okay, it just tells you everything's okay. If stuff is not okay, it has a textual summary on top, which says exactly what is not okay. And it also has somewhere down on the list, it would say active client nodes, 1 down out of 10, right? Okay. And it also shows you some of the kind of current load and latency, and it shows you the available space, because the first question everyone asks is, how much available space do I have, right?